Algebra 1, Lesson 92. We are looking at simplifying complex fractions, especially being able to divide two different fractions. So normally when we divide things, we see it kind of like this. A over B divided by C over D, with that division symbol. Now we're going to be seeing them with the division bar to separate two different fractions. We haven't seen that all that much. So let's try it with this first one. And of course, we're going to use the same method that we normally do in order to divide fractions, which is copying the first one. So in this case, a over x. Our numerator is always that first fraction. Okay, and then we're going to multiply by the reciprocal of the second one. So we're going to do a plus x over b. Now to multiply these, we don't need any common denominators or anything, but we do need to distribute this a to everything on the other side. So we get a squared plus ax over xb. The other way that we could have kept it is in factored form, like a times a plus x over xb. Now this is actually as simple as we can keep it, because these x's cannot simplify. The x on the denominator is a factor, but the x on the numerator is not, because currently it is connected to something else with that addition sign. Let's try it again. B over y divided by y over a plus y. So we keep the b over y, then we multiply by the reciprocal a plus y over y. And we simplify to get ba plus by over y squared. Once again, those y's cannot simplify. All right, let's do a couple more and make sure we simplify as much as possible. So we get am over n times mn over x. Now we could go ahead right here and simplify the n's, or we can multiply it out and get am squared n over nx, and then simplify the n's to get am squared over x. Second one here, bt over as times st over r. And I could simplify the s's here and to get bt squared over ar just by multiplying it out again. Now, they can be this simple, but they're not always this simple. Sometimes we have to do a little bit of factoring in order to simplify things. So in this case, I'm going to write it out, x squared minus x over 9 times the reciprocal, 3x over x minus 1. Now, I am going to factor before I multiply in this case to make things a little bit simpler, so that I get x times x minus 1, just factoring out an x in the first, times 9 over 9 times 3x over x minus 1. Now, this x minus 1 and x minus 1 are factors that I can simplify. I can also simplify the 3 and the 9, so that I end up with just x squared over 3. Okay, much simpler than where we started, but that only comes with factoring. All right, this next one, I'm going to go ahead and factor while I write it out. So I get 3x over 6 times x plus 2, just factoring out a 6 times the reciprocal, x plus 2 over 9. Now the x plus 2's can cancel out. The 3 and the 6 can cancel out, and I'm left with x over 2 times 9, or 18. Now, what we've been doing in the past is a fraction divided by another fraction. In this example, I have a fraction divided by not just a fraction, 1 minus 1 over x, which means I need to get this to a place that is actually a fraction over a fraction. Now, in this situation, in order to subtract something that is a fraction, I need common denominator. So I'm going to have to change that 1 to have a common denominator of x. Well, that means I need to multiply by that denominator, so x over x. So I end up with my same 1 over x over, well, I now have x over x, that's my 1, minus my same 1 over x. Now that these are common denominators, I can actually subtract them to get 1 over x divided by x minus 1 over x. Remember, you subtract the numerators but keep the denominator. So I can go ahead and copy down that 1 over x times the reciprocal, x over x minus 1, which means these x's can cancel out and I am left with 1 over x minus 1. Okay, but we had to get it to a place where it was a fraction divided by a fraction before we did anything else. We're going to have to do the same thing here, but in this case, my 1 is going to have the same denominator of x plus 1, which means I have to multiply by that denominator in numerator and denominator, because x plus 1 over x plus 1 is 1, so that I get x plus 1 over x plus 1 minus 1 over x plus 1, all of that over x over 2x. And I'm going to do some simplifying here in both numerator and denominator. So I do x plus 1 minus 1, okay, in the numerator of this big numerator, and I end up with just x over x plus 1. Then I'm going to simplify here to get x and x go away, so I'm just left with 1/2. So I actually am going to multiply by the reciprocal. Okay, this is 1/2 now. So I multiply the reciprocal 2 over 1. And I'm left with 2x over x plus 1. And that's as simple as I can go, since those x's are not both factors. Okay. Now, sometimes we have to use these skills in order to find rates or distances based on some different expressions. So in this case, it took Max 3x squared minus 12x over 3x minutes to speed walk to the gym. That was 5x minus 20 over x cubed miles away. Find the rate in miles per minute. Now, our normal distance formula tells me distance equals rate times time. Well, I want to find that rate, so I plug in my distance, plug in my time. So distance is 5x minus 20 over x cubed. And that equals my rate times 3x squared minus 12x over 3x. Well, the only way to solve for rate is if I divide my 5x minus 20 over x cubed by 3x squared minus 12x over 3x. So I need to divide these different figures. Okay, so I'm going to actually erase a little bit here so I have some space to work. So I need to do some division between these two expressions. So once again, I copy, I multiply, and I flip. So I have 5, and I'm going to factor 5 times x minus 4 over x cubed times the reciprocal. So 3x over 3x times x minus 4. Now there's some simplification that can happen. The x minus 4s can go away since they're factors. The 3x and 3x can go away, and I'm actually left with 5 over x to the third. That is my rate in miles per minute. Now I can use this information to now say, if it takes Max 25 minutes to walk to the store, that's 1 mile away, what is x? I go back to my original distance equals rate times time and plug in what I know. Now I know that the distance is 1. I know that the rate is 5 over x to the third, and that the time is 25 minutes. So I need to solve for x to the third. So I start multiplying, and I get 1 equals 125 over x to the third. And I think to myself, well, what is the only way that I can take 125 and divide by itself, it looks like, to get 1? So x to the third must be 125. So x must be 5. Lots of other ways to solve that, of course, but with logic we can see x has to be 5. So x in our rate, in this case, is 5. Okay, similar situation. On her bike, Emily can make it to her school that is x miles away in 3 plus 4x minutes. If Jason's house is 1 over x miles away from school, how long will it take Emily to get there from her school? Okay, so we have this situation, and Emily can make it to the school in 3 plus 4x minutes. All right, let me just check something really quick. All right, so if we have this, we need to figure out what is her rate, because we have the miles and we have our minutes. So we can say her rate is x miles for every 3 plus 4x minutes. That's her rate in miles per minute. Now, if she were at Jason's house, which is 1 over x miles away, how long will it take Emily to get there from her school? So I want to figure out, okay, if the distance, okay, distance equals rate times time. If the distance is 1 over x and the rate is x over 3 plus 4x, I want to find the the time, by dividing by x over 3 plus 4x. So I need to divide these two things. So I use my normal methods and say I'm going to copy down 1 over x and multiply by the reciprocal, 3 plus 4x over x. And I realize that it's going to take her 3 plus 4x over x squared minutes to get to school. Okay, so I figured out her rate, and then I plugged it into the original distance equals rate times time formula in order to find the time that I was missing. All right, well, I hope this helps for homework and for studying.